Annually, floods wreak havoc, displacing millions and incurring massive economic losses. These catastrophic events not only leave a trail of destruction, but also a profound impact on the lives and livelihoods of those affected. The ability to anticipate and accurately predict these floods is therefore of paramount importance. However, traditional methods of flood forecasting, while valuable, have their limitations. This is where the power of technology, and more specifically artificial intelligence, comes into play. AI has the potential to revolutionize flood forecasting, providing the accuracy and efficiency needed for effective disaster management. It's not just about predicting the occurrence of floods, but also about determining their severity and impact. This could mean the difference between life and death, prosperity and ruin for countless communities around the globe. Today, we delve into the transformative impact of artificial intelligence on flood forecasting, offering a beacon of hope for a safer tomorrow. Traditional flood prediction hinges on stream gauges measuring water levels. These devices, often situated along rivers, are the unsung heroes of the scientific world. They continuously monitor water levels, sending real-time information to meteorological centers. Scientists then analyze this data, predicting possible flood events. However, this approach has its drawbacks. For starters, the distribution of these gauges is uneven, with a majority located within developed nations. Developing regions, unfortunately, miss out due to lack of infrastructure and resources to maintain a network of gauges. This leaves vast swathes of land, home to millions, vulnerable to the devastating effects of floods. Moreover, traditional methods lean heavily on historical data. While this provides a useful baseline, it does not account for the unpredictability of nature. Unusual weather patterns or sudden extreme events can cause unexpected floods that catch communities off guard. Adding to this complexity is the looming threat of climate change. With the planet warming, weather patterns are becoming increasingly erratic. We're witnessing more intense and frequent rainfall events, which in turn lead to more severe floods. This trend is particularly concerning for areas already prone to flooding. Furthermore, traditional models are limited in their predictive time frame. They can often only predict floods a few hours or at most a day in advance, leaving little time for communities to prepare or evacuate. Finally, the accuracy of these methods can be influenced by a number of factors. These include the quality of the gauge data, the complexity of the river systems, and the impact of human activities such as dam construction and deforestation. All these elements can skew predictions, leading to false alarms or missed flood events. In summary, while traditional methods have been instrumental in flood prediction, they are not without their shortcomings. Uneven gauge distribution, reliance on historical data, limited predictive timeframes, and the increasing threat posed by climate change all highlight the need for a more robust approach. Climate change exacerbates flood frequency and intensity, particularly in these data-deficient regions, necessitating a superior solution. Enter artificial intelligence. Scientists have devised AI models trained on existing gauge data. It's a game changer in flood forecasting, setting a new standard in predicting these catastrophic events. So how does it work exactly? Picture a vast network of neurons, each processing pieces of information, learning, adapting, and refining their understanding of the world. That's the essence of AI. These AI models are trained using historical data from stream gauges, satellite imagery, and even social media posts. They learn from this data, identifying patterns and correlations that humans might miss. And here's where it gets really interesting. Once trained, these models can extrapolate this knowledge to areas where we have little to no data. Imagine a remote village in a developing country, far removed from any stream gauges. Traditional methods would leave this village vulnerable, with no way of predicting an incoming flood. But with AI, we can now forecast streamflow in these ungauged regions. The AI model can analyze similar regions with available data, apply its learned patterns, and make a prediction. But it's not just about making predictions, it's about making accurate predictions. And AI is proving to be remarkably accurate. By leveraging massive data sets and advanced learning algorithms, these models can predict the likelihood of a flood with incredible precision. The real power of AI in flood forecasting lies in its ability to provide early warnings. Time is of the essence when dealing with floods. The earlier we can predict a flood, the more time communities have to prepare and potentially save lives. But the potential of AI doesn't stop there. Scientists are continuously refining these models, making them more accurate and efficient. As we gather more data and develop more advanced AI algorithms, our ability to predict floods will only get better. These models can furnish flood alerts where traditional methods falter. The power of AI in flood forecasting is undeniable, and its potential to protect communities and save lives is truly remarkable. AI is not just a tool, it's a beacon of hope, shining a light on a safer future for all. Let's juxtapose AI with traditional methodologies. You see, flood prediction has been a science that has largely relied on tools like the Global Flood Awareness System, or GLOFAS. This system is a marvel in its own right, using real-time data from gauges and weather satellites to generate flood forecasts. However, GLOFAS, like any traditional flood prediction system, has its inherent limitations. It's primarily reactive, in the sense that it uses current or imminent data to predict floods. This approach may work fine for some regions and scenarios, but it often falls short in providing enough lead time for communities to prepare or evacuate. Now, let's shift our focus to the AI model. What sets it apart from traditional systems like GLOFAS? It's all about its predictive power. The AI model doesn't just react to current data, it learns from historical patterns and uses this knowledge to make forecasts. And not just for the next day or two, but up to 5 days in advance. Imagine the power of that kind of foresight. A 5-day lead time can be the difference between a community being blindsided by a flood and having ample time to prepare or evacuate. It can mean the difference between significant loss and minimal damage. But it's not just about the advance warning. The AI model also outperforms traditional systems when it comes to accuracy. While GLOFAS can make valuable predictions about current or imminent flood risks, the AI model goes a step further. It leverages vast amounts of data to make precise predictions about water flow in regions that may not even have gauges. So, how does this advanced warning and superior accuracy translate into real-world benefits? Think about the lives that could be saved, the properties that could be protected, and the communities that could bounce back more quickly after a flood. Research indicates the AI model surpasses GLOFAS's accuracy by prognosticating floods 5 days ahead. This is not just a technological advancement, it's a tool for resilience, a beacon of hope for communities around the world facing the rising tide of flood risks. Timely alerts are paramount. In the world of flood forecasting, the adage, "forewarned is forearmed," holds true. Early warnings are not just about predicting an event, but also about buying precious time that could mean the difference between safety and disaster. Imagine an AI system that could provide a 5-day lead time for potential flood events. With this advance notice, communities would have time to prepare. From fortifying homes with sandbags to evacuating vulnerable areas, every minute counts. This isn't just about protecting property, it's about preserving lives. Now let's think bigger. What if we could anticipate not just the ordinary, but the extraordinary? Floods are not all created equal. Some are routine, others are once-in-a-century events. These rare catastrophic floods are the ones that leave lasting scars on communities, both physically and emotionally. Here's where our AI model really shines. It's not just about predicting the next flood, it's about understanding the patterns and trends that could signal a catastrophic event. By analyzing vast amounts of data, the model can identify the conditions that lead to these extreme events. This means we could potentially have years, not just days, to prepare for these devastating occurrences. Just imagine the long-term mitigation strategies that could be put in place with this kind of notice. Infrastructure could be improved, protections could be built, and communities could be better prepared. It's about resilience, not just response. So by harnessing the power of AI, we're not just improving flood forecasting, we're transforming it. We're moving from reactive measures to proactive strategies. We're giving communities the tools they need to protect themselves from the unpredictable and often devastating impacts of flooding. Moreover, the AI model can anticipate rare, catastrophic floods, facilitating long-term mitigation strategies. AI-driven flood prediction harbors immense promise, particularly for resource-constrained regions. As we step into the future, the immense potential of artificial intelligence in transforming flood forecasting is becoming increasingly evident. By leveraging the power of AI, we can significantly improve the accuracy of flood predictions and ensure early alerts, saving countless lives and minimizing property damage. But it's not just about the here and now. The beauty of AI lies in its ability to learn and adapt. As we feed it more data, these models will only get better, providing even more accurate forecasts and longer lead times. And it's not just floods. The same principles can be applied to predict other natural disasters as well, making our world a safer place to live. The integration of AI into flood forecasting is a game changer. As we continue to fine-tune these groundbreaking models, we edge closer to a future where no community is left vulnerable to the devastating impact of floods.